Hey guys, morning. So this week for my experiment, I've chosen Heat It Up. This is from this PC Year 3 Chemistry Primary Connections of Melting Moments. And I've chosen lesson 2, which is called Heat It Up. So just a bit of background information. The Literacy General Capabilities is literacy focused and provides students with the opportunity to use them as they think, reason, and represent their understandings through science. With an example of this is playing different roles in the experiment and writing up tables. The numeracy capabilities includes measurement and collection, representation and interpreting data. For example, for this experiment, collecting and interpreting data through tables and graphs. And so today's experiment, what I'm going to do is I have 6 food items and we're going to see if it melts or doesn't melt. So how we document this is by this sheet. So on one side you write it's before we melt it, so that you draw what it looks like, write what the item is, and you select if it's a solid or a liquid. Once you melt it, you then do the same thing, draw what it looks like, write what the item is, and then what's it turned into, if it's still a solid or if it's melted, so a liquid. So the kids will do that for every different food that we do. Some health and safety precautions before we start. Do not eat the food. What I'll have, especially because we have chocolate, so kids will be tempted to eat the chocolate. So how I would stop that is say, at the end we have some chocolate. If you conduct the experiment correctly, you can have some chocolate. Because we're using heat, the kids would have to have gloves, like the mask?
Heat protectant?
Yeah, to help them, and also because I'm using oil, so some items can splat, so kids can wear safety goggles. Girls' hair would have to be tied back, boys' hair, so it doesn't catch on fire. When they're using the paper, keep the paper flat so they won't get a paper cut. And yeah, just to be mindful of other students, because as there are going to be different kids around the classroom, you're going to be tight, you're using hot things, just be mindful to stay in your area. So the items that we have to melt is we have sugar, chocolate, oil, a potato, ice, and butter. So they're the 6 food items we are going to melt. Does anyone have an initial hypothesis about which ones are going to melt?
Ice is going to melt the easiest.
Yeah.
Just to its state.
Same as butter though. Butter melts real quick.
Yeah.
Chocolate's
going to melt as well.
What was that?
Oil eventually melts. But I feel like that would take a long time,
Yeah.
depending on how much.
It has ice, butter, and
Chocolate?
What were the other?
chocolate. I feel like chocolate takes a while.
Yeah.
Chocolate is quite thick.
Yeah, and I also have a potato. It's like a quarter, so they're all the same size.
I don't think
I
that'll
think
melt.
that's just going to cook.
Yeah. Yeah.
What was the other one? Did you say you had sugar?
Yeah,
Sugar.
just
Yeah,
plain
I
sugar.
think it's just going to burn if we leave it there too long. It's not going to melt.
Yeah.
No.
Yeah. Sugar
I
turns
feel
kind
like-
of.
I feel like
Yeah.
all the items are either going to melt or partially melt besides the potato and the sugar.
Okay.
Yeah, the sugar.
Yeah. I feel like the sugar could melt though.
It
Some.
could work.
I think after a while, if it really sits there.
I think if you stir it, yeah.
Yeah.
Are we gonna time how long they cook for? Time.
How long it melts.
Okay.
Yeah, so
Until they
it's like a fair test. I feel like because with sugar you need another substance like butter, you need to mix it with something.
Yeah. So between
Sugar alone, I feel like it will start to burn.
between each experiment, I am going to wipe the pan out, so that it all has the same base, so it's not all melting together.
Yeah.
Would someone be able to time it? Each experiment?
Yeah, I can do that. How long do we want to do it for?
Do you want to do
How long should we give it?
30 seconds?
Maybe a minute, so that it's
Yeah.
Yeah. Okay.
Okay. Tell me when you're ready.
Okay, so we'll start with the potato.
Wait, what was our initial hypothesis first.
Okay, so the initial hypothesis is that the ice and butter are going to melt quite quickly. Like the chocolate will melt, however, will take a little while. The oil will melt too. The potato will not melt, it will just cook, and the sugar will just burn right away.
And then why do we think
Is everyone think so?
Do you have ice as well?
Pardon?
Do you have ice as well?
Yeah.
No. You do? Okay.
Yeah.
Ashley, are you putting any like spraying oil or anything down first, or just
No,
straight on?
just straight on, because the spray oil could change the consistency and things.
Yeah.
Okay, so we're going to try melting the potato first. So it's just a little cube of potato.
why do we think it's not gonna melt though? Like what's our because for the initial hypothesis?
I think it's just because it's such a solid. Yeah. Usually with vegetables, you want to boil them or cook them, but they don't actually get to the point where they melt.
Mm.
Yeah,
I feel like the first, like the butter and the ice and the chocolate is more of a lifestyle thing that we would melt.
Mm. The only thing is,
I would have never seen a potato try to be melted.
but the other thing is
So
potatoes.
it's like a lifestyle choice. Yeah.
Mm.
Like personal experiences.
No. The only other thing is it does have a lot of water in it, so that could change
that's so
it.
true.
Okay, are we ready to time?
Yeah.
Okay, ready, go. And we're just gonna leave it still.
I
We're
feel
not
like
gonna
in a
move
minute
it.
nothing's going to happen now that I think of it.
Well, it could get black on the bottom, maybe.
Yeah. It's going to get hot, but it won't decrease in size.
Yeah.
I'd say the bottom half of it is just going to start to cook a bit.
I also
and potentially burn.
I also forgot to say in my safety, the kids will be using tongs to remove the items as they are hot and they don't touch it.
What year level did you say this was for, Ash?
Year 3.
Yeah.
But I think normally they'll be using like Bunsen burners and different stuff, not a pan.
Yeah. And with teacher supervision
Yeah.
as well, yeah.
So this is sizzling at the moment.
We've got 10 seconds left too. I can hear it sizzling.
And it's like on a
Do you think that's is releasing?
pardon?
Okay, that's a minute.
So it hasn't melted. It's just hasn't even burnt or anything. It's just
Oh.
Yeah,
So-
see, that's what I thought. I was like, feels like nothing's going to happen.
it's just
I feel like if
warm.
we left it there for longer, it definitely would have started to
Yeah.
cook. But
Yeah.
Yeah.
I don't think a minute was going to do anything.
Yeah.
And then would we get the kids to wipe it, or do you reckon we should get the teachers to wipe over the Bunsen
I
or the
think-
pen, whatever, when it's when they're doing it?
I think we'll
I'd
have like
say
the
if they're doing it, we would need teacher supervision for each group pack to make sure that no one touched it.
or the
Yeah.
teacher would conduct the experiment and have the students like participating and like having their answers and documenting everything.
Yeah, I like that idea.
Because
And like
otherwise,
rotations of like a group will do like the potato and a group could do like the ice and stuff. Yeah, that'd
Yeah.
be good.
yeah. Okay, so the next item is the ice. So I got that straight out of the fridge, so it hasn't been in anything yet.
How hot is the heat as well, Ashley?
It's on a small pan, like small syringe, but on the highest one. Highest level. Okay, are we ready for the ice?
Yep. 3, 2, 1.
So they're moving around a lot.
They're melting
It's like
so-
melting instantly.
Yeah.
Yeah.
And it's like bubbling.
Like
Yeah, well,
it's
they
fully
usually melt without heat as well. So
Yeah.
Yeah.
The only
And
thing,
they're bubbling too, okay? The water's bubbling.
the only thing is because of my hands going from the ice to here, it could also infect it.
Yeah. It's like definitely changed substance already.
Yeah,
Yeah.
Already melted.
it's like all water now.
It's water.
Yeah, that's like fully melted now.
And now we're boiling it really, so it's making a gas too.
Yeah, so it's turning because you can see all the
Clever.
steam.
Wow.
Do we have to draw the pictures as well?
Yeah, so they have a before and after drawing.
But do you think that we should probably like let the kids do them like one by one
Pardon?
after the potato? That's the time.
Yeah.
After the potato, like we draw one before we put it in, and then after we do
Yeah.
the same. And,
Yeah.
yeah, straight after, so they remember better.
Yeah.
Yeah.
So if like for in the classroom, every experiment would be taken like, okay, so this is the potato, draw it, this is what happens, okay. Now we conduct the experiment, everyone stop, this is what's happened, then they like draw it so it's all consistent so they don't have to remember what happened.
Yeah.
So that's at the end of the timer, so the water has fully dissolved and it's all liquid now. So I'll just pour it out.
That would also be dangerous for students.
Yeah.
How quick it started burning.
Yeah, you know, you probably want like a sink or something really close by to where you're working with the kids.
Because
Because you
if
wouldn't want
as soon as Ashley put it in, we could see it.
You definitely have to be in a science like lab or something to do this experiment.
Yeah, you want to be able to do it in a
Students
classroom.
near the pan at that time.
No.
So the next item we are going to melt is the sugar. So I've just got plain white sugar here, about the same amount as everything else. So are we ready to start?
Yep, 3, 2, 1.
So that's just sitting there. It's not really doing anything. I feel like if we mix it around, it could.
Yeah, it is quite piled up onto one another.
Can you mix it or that be like tampering with it, kind of?
Yeah.
Yeah, well, we haven't used any other type of tool for the rest, so I
Yeah.
feel like it wouldn't
I
make
was going to
it
say
as
to blend
okay.
it because it didn't touch the others.
Yeah.
Well, we did like shuffle the water around, so if you just shuffled it in the pan, I'd say that's okay.
Yeah.
I feel like usually if you want sugar to turn into caramel, you usually have to like really mix it, like keep going.
But I feel like
Totally
don't you
agree.
also have to put like something else in it?
Yeah, usually.
Butter.
With the
That's the timer
oh wow.
to go.
Probably just
So
warmed up. Hey?
Is there any like color difference in any of them?
no, it's all the exact same.
Wow.
It's just warm.
I feel like if we again left it for longer, it would have started to burn and stuff.
Has any of it stuck to the pan, like just a little bit?
No, not yet.
Okay.
It's all still like raw sugar, just warm.
Maybe a minute is long enough then. Like for sugar and potato, obviously.
Yeah.
Yeah.
With the amounts of stuff that you chose, did you pick that from the book or did you just like?
They had suggestions. So like they had like the chocolate and water, and then I just chose the others. So for this experiment, the teacher has to know beforehand what melts and what doesn't melt. So I chose 3 items that melt, 3 items that don't melt. So then it's up to the students to determine what they think, and like some of it is like tricky. Like they could think, oh, it will melt, but it won't. So it gets them thinking. The next will be the chocolate. So it's just plain Cadbury chocolate, 4 pieces. So they're all around the same size and quantity, all of the different fruits. So then it keeps it a controlled experiment.
Yep.
Ready for the chocolate?
Yep. 3, 2, 1.
I feel like a minute is a small amount of time, so it's quite
It might
interesting to
melt
know
on
what
the bottom.
happens.
Yeah.
I feel like it's gonna melt the slight bit because like the pieces are quite thick. But
Yeah.
Yeah.
if it was on there for
Maybe
longer,
just as the minute finishes, you'll see like a little bit of it melt.
Is it starting to melt now? Like at the bottom?
can you like shuffle it around like you did with the
No,
I
it's
feel like
staying.
if you leave it there though, then it will actually.
It's like staying still. But like I can't move it with the tongs because that will change the experiment. But no, it's like definitely stuck there. Oh,
oh
it's sliding a
it's
little.
Starting to melt.
But you can like tell.
that's the timer.
So if you pick it, yeah, that's like really squishy now. So it's like
Yeah.
Yeah, so it
It's-
has
so
melted.
it-
just
yeah.
not completely.
it's broken in half. It's dripping. So it has melted, but
Or
not
if you
fully.
just left it there for another minute, that half piece would have been a melted piece instead of a melted.
Yeah. But now that the heat's off,
Yeah,
it's
it's definitely melted, but just not the whole substance.
yeah. And now that the heat's off, it's actually starting to like kind of harden again back to it.
Whoa.
So that's something for like the kids to know that like it can form back to it and make a solid, not necessarily fully go liquid.
Yeah.
I think it's definitely good that like if we were to teach this in our classes that we would have to practice like at home to see how long we should melt it for. Because like
Exactly. It's like for like teachers being prepared what to teach the students. They need to know it beforehand.
yeah.
It's all about like trial and error, I believe. Yeah. Like we're just trialing the 1 minute as the experiment, but then if you want to get it as like 5 minutes, you can see that's becoming too much for the experiment to work.
It would have been reasonable if like Ashley tested it out for 2 minutes and she went and did it in the classroom for a minute.
Yeah.
I think we would have a different view on it.
Yeah.
The thing
But
with
at least it's good for like a minute enough for the chocolate like to fully melt.
the thing is also with the chocolate, the smell changes. With all the other items, with all the other food items, the smell has stayed the same of what it is. Unlike the chocolate, it turns to like more of a sweet smell. The next thing we can melt is butter.
Just pretty quick, I assume.
So this is just the
Oh, okay. So this is like margarine butter.
yeah, flora.
Okay. I would
Yeah,
expect
they can melt pretty fast.
butter like the cube butter,
Pardon?
like butter the square piece butter.
No, it's just like
cooking
out of the
butter.
container that
Yeah.
you just. Okay, ready?
I feel like
This one's definitely a lot easier to melt than the other butter.
Yeah.
yeah.
Okay, 3, 2, 1.
Even that would be an interesting experiment to see like between the different butters.
Yeah, that's what I was thinking. Because the other one's a lot harder and like stuck together.
It's also like say with chocolate to see what different types of chocolates melt.
Yeah.
See, that started melting like
This is not-
instantaneously as well,
Yeah.
like the water did, like the ice
It's
did.
already so soft.
It's already like
Is it?
bubbling.
Yeah.
The only other thing with that could change the experiment for the butter is it's been sitting out for a little.
Yeah.
So that could make it melt quicker compared if it came straight out of the fridge.
Yeah.
So yeah, so this is sizzling now.
It would have been harder because it would have been colder if we took it straight out.
Yeah.
Yeah.
And it's like fully liquid now.
It's like sizzling a lot.
Yeah.
doing the
also
same, like
quite
part
a lot.
turning into like gas again.
Pardon?
Yeah.
There's the timer.
What did you say, Rihanna?
The timer just went off.
No, before that.
Oh, it's like partially turning into a gas again, like the ice did.
Yeah.
Like it went from a solid to a liquid to a gas.
Yeah. But the thing is now with the butter is when you tip it, it's not really moving. It's all kind of evaporated.
Like melted onto the pan.
I guess that's why you use butter sometimes before you like make pancakes or something, because it's a sticky variable. Like it helps the other ones not stick.
And then the final thing we are going to try and melt is oil. So the thing with this is oil can be quite dangerous, as when it gets hot it can spit up. So I feel like the students wouldn't be able to do this one. The teacher would have to do it, like pour it in, like kids can like stand back with like goggles on, but like still so they can see it. So this one we said is going to melt. Do we still think it's going to melt?
I think some of it will like evaporate, but
Because it's already in liquid.
Yeah. But it's like a
It'll just
thick
heat up
liquid.
and like bubble or something. I don't know.
The
I
thing
don't
is,
think it's gonna melt because it's already like a liquid.
Okay, how does it actually melt?
It's not exactly. That's what I'm confused about. Like, how does a liquid melt?
like it's,
Yeah.
but it's a thick liquid. It's not like water.
Yeah.
Okay.
I feel like maybe some of it will stick onto the pan, like the butter.
Yeah. Well, because it's oil, so it's like you use oil to like de-stick things too,
Yeah.
though.
Yeah, exactly. And it's really easy. Like when
Yeah, I don't
you use it
think
with
it's
food,
like a-
you don't see it anymore.
I think
Yeah,
it will just like,
evaporate.
I think it'll end up like the
It'll melt,
butter.
It'll evaporate, yeah.
Yeah.
It'll evaporate.
Okay, we ready?
Yep.
No.
Ready and go. So it's like all moves at once.
I guess there is a lot of it. So.
It is kind of disappearing because it's like shrinking into it. And like it's just like
Yeah.
split in half. So it's kind of disappearing.
I can tell with this one on the left hand side, you can't really see it anymore.
Yeah, like there's one here and there's one there, and it used to be like together, and it's like all disappearing.
Yeah, it's
Yeah,
cool.
definitely.
Yeah.
Oil.
It's kind of just going into the pan.
Yeah.
Yeah, I think it's evaporating. That's a timer.
So yeah, so it's kind of all disappeared. Like there's definitely not as much in it as it started off.
Yeah.
Yeah.
Also, the smell has changed for this. You can actually smell the oil compared to the others when you couldn't smell other things or before it.
Wait, can you smell?
Pardon?
Like, what do you mean? What do you mean? Like, what can you smell now?
You can smell the oil.
Okay, but before you couldn't.
Yeah, so before it just it didn't smell like anything, but now once it's heated up, it actually smells like stuff.
It definitely like brings like a stronger smell once you start melting it. Like with the chocolate, you said the smell changed.
Yeah.
Did the butter different?
No. But also with the oil, I think if it was on a hotter heat, it would start spitting, but it didn't spit. It just evaporated. So I think if it was on a different heat, it could have different effects.
Yeah, or the other way.
Yeah. So our observations. So obviously what we saw, we noticed what melted, the chocolate, the butter, the ice, compared to other things. That like the potatoes stayed the same. Did anyone notice any patterns? with what melted and what didn't melt?
I feel like I don't know how to put it, but it's like butter, chocolate, and ice. Like they were. Well, I think ice, like that's a liquid first, and then you freeze it into a solid. And like butter is still a solid, but I don't know, like it's super soft anyways. Like it's not hard like a potato.
Their textures aren't like a potato texture. Like a potato is like way harder to begin with than what a piece of chocolate and butter is like.
But I also feel like some things are made to melt. Like ice and butter are kind of made to melt. Unlike a potato or sugar, you don't really want to melt them.
Potatoes are like for boiling and stuff like that.
Yeah.
Yeah.
But I think if we had like,
The cooking, like the everyday cooking utensils could melt or like evaporate, but the others that you wouldn't use to help cooking stuff cook like their individual way.
yeah.
Does that make sense?
But
So
even with sugar, like when you put sugar in water, I know it's different, but like when you put sugar in water, that evaporates.
yeah, it dissolves.
Yeah, it dissolves.
So it's kind of
So
melt.
So it's a mixture of them both.
Yeah.
Yeah.
It's kind of like if we cut the potato up smaller, then it could like dissolve a bit more, like make mashed potato. Compared to if you just left it as a solid. Right, so our final hypothesis, is it the same or do we think it's changed?
What was our initial?
So our original hypothesis was the ice and the butter will melt easily, the chocolate will melt but will take a while, oil will melt, potato will not melt, and the sugar will burn. So to start with, so the ice and butter did melt very easily, took a couple of seconds. The oil did not melt, it actually evaporated. So it kind of stayed the same consistency.
Our original hypothesis is correct, except for the fact that we said the oil's going to melt. We should have said it should evaporate. Otherwise, the rest of our hypothesis sounds pretty good to me.
Yeah, except for the sugar.
Because the sugar didn't melt.
No, the sugar didn't melt nor burn. So we said it was going to burn, but the sugar stayed the same. It just heated up.
But the sugar would have, I feel like, burned if we left it on longer.
The
Like,
same
you
with the
did say it
potato.
went warm. It just get warmer and then get hot.
Yeah.
That's like the potato too. If we left those variables, if like the variable was a longer time, they would have definitely burned.
But that's the thing I
Like
think.
we wanted it as well.
Pardon?
Like when you put a potato in heat, it shrinks, like it gets smaller. So that would happen if we like left it longer.
Well, I think,
Because of the sugar.
That's felt like it for me.
yeah. All of the items would burn eventually,
Yeah.
except for the ice. But yeah.
But then with the
Simply what happened in a minute.
Sorry, say again, Sav.
It's pretty interesting to see what happens in a minute because it's such a small amount of time.
Did you say something earlier, Georgia?
with the oil, I think there's more links to like the alternative conceptions. But with the oil, like since we thought it would melt, and it's kind of like it does melt in a way. Like if you think of a kid watching it and it disappears, and if they don't know about evaporation yet, I don't know when they learn about that. But if they don't know about evaporation yet, it could be really confusing to them seeing it like disappear.
That's a good point.
Yeah,
I think
I like it melting.
if they learn evaporation in year 3, they would be able to, like if they learn evaporation before they learn about this, they'll be able to like do it and understand. However, if they don't know about evaporation, oil wouldn't be a good item to pick because the kids wouldn't understand where it's going.
Yeah.
And the thing is, it also could change between different variables. So I use vegetable oil, so it could change between peanut oil or olive oil.
Yeah.
So it's all just depending on what variable we use.
So wait, what was our final hypothesis?
So our final hypothesis was ice and butter melt very easily compared to the chocolate they melted quite quicker than what we expected. The oil didn't melt, it evaporated. The potato and sugar stay the same. Or stay the same? So the CDSU for this concept, what is it, and how does it compare to our final hypothesis? So the CDSU is like our background information originally, I think.
So
like our general capabilities.
pardon?
So it's kind of like our general capabilities, like the literacy and numeracy capabilities. So how it deals with like measurement and collection and representation of data, or like how students think, reason, and represent their data. How does that align with our final hypothesis?
Well, I mean, we were able to work out our final hypothesis from the data we collected in the experiment.
We're able to like...
Is it? Go on.
Do you say something, Ree?
I think we can't hear her.
Yours is muted. Yours is muted. We can't hear you. Nah.
Still can't hear you. You might have to leave and come back.
Yeah. Does anyone else know like how it compares with our final hypothesis? Anyone has an idea?
Well, does the CDSU also relate to like the scientific, like, you know, the scientific understandings? So we have the scientific understanding that like the butter and everything will melt.
Yeah.
It's working.
I can hear you.
God, there's been so many like beeps and stuff from all these things.
Keep going, Georgia.
But yeah, like that will melt. And obviously, I mean, I don't know all of like the CDSU, like the scientific understanding for it thoroughly, but I feel like we said, like the softer ingredients that we use, like the butter or the ice, that was a liquid first, and the chocolate are going to melt quicker.
The thing is with that, I think as like adults, we know what kind of melts and what doesn't melt compared to kids. Like they may have no idea that butter melts.
It's more of like knowing it from personal experience, because we've already used those substances before. Like for students, if they've been doing it for the first time.
I feel like students would have some prior knowledge though. Like I feel like they would know that chocolate and butter and ice would melt from their like life experiences, but like the other three would be the ones that would really trick them up on whether they would think it melts or not.
Yeah.
Especially the potato.
That's only, I feel like, if kids like help in the kitchen. If say kids never go in the kitchen to help mum or mum and dad don't show them anything, like they'll have no idea. So it's kind of like depends on their background.
Would obviously be the ice though. Like I'm sure that they would know that ice would melt, but the rest would be whether they've been exposed to it at home or not.
Yeah.
You could even do like a thing with them with the chocolate, like make them hold it in between their fingers, because you know how like on a hot day it'll melt. Like if you just
So they could know about it from that too when children hold, because they sometimes squeeze chocolate.
That'd be so cool for like an experiment. Like they all have to go sit outside and hold chocolate. See what happens.
Surely they'd eat it though.
Yeah.
Even ice on the hand, that's interesting, just even holding it in their hand.
Yeah, to see how their heat contracts on there.
Well, I think as well with the CDSU, with like the whole thing about the oil and evaporating, like that's a part of the scientific understanding that they would need to know for this experiment if we were to use oil. Otherwise, that could confuse them.
So the science contact knowledge. Do we have anything for that?
What did we learn?
Yeah, what did they learn from the science contact knowledge?
Well, they learned that like the softer ones, or like liquid ones, melt quicker.
Yeah.
I feel like we had like a then like the one that we were like a little uncertain on would have been the oil.
Yeah.
Like I think we all at the beginning thought, oh, it's melting, and then we thought about how oil works, and then we realized no, it's like evaporates eventually.
But that's also with the butter. I think the butter also started to evaporate.
Yeah.
I see kind of like liquid as already being melted, because if when you melt something, it becomes into a liquid.
Yeah.
So liquid would react differently.
Yeah.
I think that was a good point you made about the chocolate too, when you melted it, that it was already starting to like become hard again, like reform into a solid after melting. So I think that could be like an important thing to cover with them too, like showcase that even the liquids that can, like the solids that have been liquids that can melt, can reform into the solids if they're cold enough.
Adapt to the environment that it's around.
Yeah. So like even the ice melting into water, you can just melt the water back. Put the water back into the freezer, and then that's ice again.
Yeah.
Yeah. Yeah, true.
Obviously, you'd have to explain that if you want it to be an ice cube, you'd have to put it in the ice tray. Otherwise, it's going to be a different size
Shape.
and look
Yeah.
like shape and all.
Yeah.
And that's the same with chocolate too. Like if you think about like a chocolate bar that's been sitting in your car or something, when it melts and then you go to eat it and it like doesn't look the same. Like if it was the square chocolates, they wouldn't be square anymore.
Yeah.
Yeah.
I think it can freeze things back, but it doesn't necessarily mean they're gonna freeze back. But there's still the same amount of substance there that was there before we melted them.
The thing
I
is
would
with
say evaporate. Some.
the thing with the ice is that can also teach students about the water cycle. And how the rain comes down, it can harden from the snow, it can evaporate, like it can go through the different cycle.
That's so. Yeah.
Okay, so students' alternative concepts.
Well, I think it's like we said, like I said it before, but with how we thought that the oil would melt, but it's actually evaporating.
Yeah, so it changes.
They could think.
They would see that it's melting, unless they had prior knowledge to that.
Yeah.
Yeah.
And then
And that's the same with the sugar, sorry. That's the same with the sugar. Like we thought it was going to burn, and it might burn if we had it on for longer, but for our time variable, it didn't burn.
Yeah.
Yeah.
So
Did you smell any difference with it?
With the what, sorry?
The sugar, did it smell any different?
A little.
A little. I feel like because it warms up, I feel like if it got hot, it would start smelling like it was burning.
Yeah, it smelled sweet. Like it still had that sweet smell, but it was only on for a short amount of time.
Yeah.
And I think like another like alternative concept would have been like they don't have that understanding of how long it takes certain items to melt. So like the sugar, they would have just thought as soon as it goes down there, it's going to burn straight away. But they it would take a few minutes.
Another way,
So
another way they could
go
do this.
into the expectation of seeing it fully melted.
Yeah. Another way they could.
And it needs more time.
Yeah. Another way they could do this experiment is by having, say, sugar, and we'll melt sugar for a minute, melt sugar for 2 minutes, melt sugar for 5 minutes, and then they can compare of the time. So then they're learning about time, and so they can then compare how long it can take.
It can be another activity of them drawing what happens after each stage, like a minute, there's 2 minutes, there's 3 minutes.
Yeah.
And it's good for the kids to like draw it so they can also visually see the difference. So if it's gone from A to B or it's gone A to A, staying the same. And
But
then,
even if we're doing it like minute and then 2 minutes and whatever, maybe they could like take a photo on like the iPad or whatever and then come back to it and draw it back into their book, because otherwise it's still changing when they're drawing, and some kids love to take their time drawing things as well.
yeah.
So I feel like it'd be to take the photos and then come back to it, like draw
You
ways.
don't want to rush it, that's
Yeah.
true.
Yeah, and that's incorporating technology into it as well.
Yeah.
Yeah.
The final one, pedagogical contact knowledge.
That's pretty much the same as what we're saying, how we know
Yeah.
beforehand.
Yeah, we just said we could incorporate math through timing it, and technology through taking the photos and all that stuff. Yeah.
Yeah, and I feel like you can discuss.
Measuring like all the items, make it like even.
sorry. You know how you had that measuring cup for the sugar?
Mhm.
With the butter, did you use a spoon?
I used a knife, but I like measured it in the measuring cup, so then it was like the same
Right.
size, and then had to put it back on the knife to put it in. But yeah, so it's
I
all
just
about the
thought like
same.
if you used a cup, it would be a lot more. Like if you scooped it with the cup, it would have been a lot more butter.
Yeah. Yeah. Sorry.
I was gonna say, is there any other pedagogical stuff we can think of? You already talked about the safety, and that's kind of like including the pedagogy too, like how we talked about with using tongs and like the oil spitting and stuff like that as well.
Yeah.
We
The
kind
other
of
thing is,
talked about it all the way through.
yeah, is like
I did at the start as well. I think that was the first thing we talked about.
yeah. Like also the alternatives for students who have like disabilities or like physical or mental. So for like physical disabilities, you could have them like taking the photos if they could, instead of actually doing the experiment. They could be the one being like the instigator, telling kids what to do, like being the leader, so they have other jobs rather than they don't feel like they're missing out.
Just still having them involved, just
Yeah.
in like a different way.
Yeah.
That's like if they had like allergies and stuff, like they can't do certain objects, or then how you said we'll have chocolate at the end. If they're allergic to chocolate, give them a reward. It doesn't have to be food, like it can be a prize or something that goes on in your classroom that's like to make up for the fact that they can't have chocolate. Like there's plenty of ways to work around that.
Yeah. And then all having like, if their kids can't have chocolate and it's their turn to put the chocolate in, they swap. They could put the potato in, or they wear gloves and put the chocolate in, so then they can just change it up.
Just comes down to knowing the students really.
Yeah.
Yeah.
Does anyone have any questions about any of this? No.
Not really. I think we did well today.
Yeah.
Yeah.
Well, I think that is the end for us today. Cool. Thank you, and I'll see you next week.
Thank you.
Bye.
Thank you. Bye.